Good evening, friends. Let us continue the chapter differentiation. In the last video, I presented the basics of differentiation from the point of view of slope. We understood that the moment we define the slope of a particular curve at a given point or the slope of a line, the information that we are getting from this slope is variation of the dependent variable with respect to independent variable. That only is called as differentiation, and in that one condition we put that the limit delta x tends to 0, delta y by delta x is called as differentiation. Now we will proceed to understand this differentiation right now with first principles. From the first principles we start applying the formula. So now I will explain to you exactly what is this first principle method of finding out differentiation. Now we avoid using the word slope because now we understood slope is equal to differentiation. Better now we start using the word differentiation, wherein we try to find out the variation of a dependent variable with respect to the first variable, that is independent variable. Okay, let us go to the whiteboard and understand it thoroughly. Yeah. Now, you should not get confused because many a time we'll be using a function by representing in the form of either f of x or sometimes we'll be writing y. Both are interchangeably used. Sometimes they'll use f of x. Like for example, if I write f of x is equal to x square, that means f of x is a function and its input is nothing but x and output is nothing but x square. So f of x is a dependent variable. X is called as the independent variable here. Same thing in some textbooks we find y is equal to x square. So here y is again dependent and x is called as the independent variable. Here, last video we have said that limit delta x tends to 0, delta y divided by delta x is called as differentiation. It is called as differentiation. Differentiation of what? Differentiation of y with respect to x. The meaning of delta y by delta x is what? Differentiation of y with respect to x. This is represented as dy by dx. This is represented as dy by dx, or you can also write d by dx of y. This is also correct. So if you represent in terms of f of x, it is called d by dx of f of x. This is also correct. So if I write d by dx of y, sometimes I will write it as, instead of writing all this, we can write y dash. Y dash implies that differentiation you are doing. For this d by dx of f of x, if I want to represent in terms of previous y dash, it is called f dash. So this notation is important. Either y dash x I can write or f dash x I can write, subject to the parameter or the variable name what we give here. Okay. So now you understood differentiation. Differentiation is nothing but variation of a function. We also used one important word called as infinitesimally small. Infinitesimally small. Here, what we are trying to do is we are trying to find out variation in the output or in the y value for a very, very small increment in the independent variable. That is, if x changes by delta x, means very small amount. If you see the table previously, some previous class, we have gone to reach 1 from 1.000005. That means very small variation in the x. For that small variation, we were finding out how much will be the y variation. For even small variation also, y will vary. That is important importance of this differentiation. We wanted to understand the minute variations. These minute variations in the output are very essential. For example, if you want to, let us say, understand how the path of a projectile changes. So path of a projectile, if you see, it is a curved graph. So that curve at each point, how it will behave with respect to various inputs. So that kind of information you will get at each point. If you find out, let us say, its behavior. For example, I have to, if you want more clearly, let us say I am drawing one velocity and time. You take velocity and time. So let us say with respect to time, velocity is changing like this. Okay. Now at this point, I want to know what is the speed. Again at this point, what is the speed? Very, very close points. So this entire path is a curved form. So instantaneous values of speed with respect to time means variation of speed with respect to time we are finding out. So this information only is called as differentiation. So we are finding here delta V by delta T in that case. That's all. Delta V by delta T. This is called differentiation of velocity, which will give you acceleration. This information is useful. So almost all fields which are dealing with various functions like economy, profit and loss, or for example in the medical side or in the physics side, everywhere differentiation is useful. So now let us understand the meaning of first principles derivations. I'm doing right now. Okay. So now let us see first differentiation from first principles. So for this, you are requested to go back to the old video and see clearly all this. Okay, the sense big fundamental will be there in that. Here also we'll repeat it, but we'll try to do it in a little bit. Means after one slide, whatever information was given there, that I am projecting now here. So that information will be available there. That I don't repeat fully, but partially will touch it. Yeah. Consider a function. Let us consider a function y is equal to, now I am changing, now I am using instead of f of x, y. This is y is equal to x. What I am asking, direct question, differentiate y with respect to x. That's what I asked. So what we do, how do we solve this? Very simple. Consider, let us say we will consider y is equal to x. Call this as equation number 1. Let, what is the fundamental of our differentiation? For a small change in the independent variable, we are supposed to measure the change in the output variable. Okay. Let delta x be a small increment, delta x be a small increment in x, and let delta y be the corresponding change in y. So now you increase this x to x plus delta x. Then y also will change because y is depending on x. So y also will become y plus delta y. So I will write here, therefore, from the above statement, y plus delta y is equal to x plus delta x. Second equation. Now, 2 minus 1. We'll do second equation minus first equation. Y plus delta y. We are having left hand side. First equation y is there. Here, second equation right hand side, x plus delta x minus x. So remove the brackets. We'll write down y plus delta y minus y is equal to x plus delta x minus x. Cancel out x and x. Cancel out y and y. Now we are having here delta y Here you are having delta x. Now divide both sides by delta x. Because our job is what? We wanted to differentiate y with respect to x. So we have to differentiate this with respect to x means what? We should divide both sides by delta x. So divide by delta x both sides and apply limit delta x tends to 0. So what we'll do now, limit delta x tends to 0. Both sides we are doing the division. Delta y by delta x is equal to. This side also we have to put same delta x tends to 0. Here we are having delta x by delta x. This one by definition just we have defined today. It is called as dy by dx. Differentiation of y with respect to x. Delta x and delta x both get cancelled. So you'll be getting this limit will not be applied at that time, directly 1. So what did you get now? Differentiation of function y, which is defined as y is equal to x, is equal to 1. dy by dx is equal to 1. So now let us understand one more sum. Differentiate y is equal to x square from first principles. So here also we start with y is equal to x square. This is our first equation. Same sentence. Let delta x be an increment in y in x, and let delta y be corresponding increment in y. Okay, same like previous sum, no difference. Then what you will get here? You'll be getting y plus delta y here, y plus delta y is equal to x plus delta x whole square. Because what is the function here? Function is nothing but y is equal to x square. So x square, when it is changing, let us say in x I am giving an increment of delta x. So it becomes x plus delta x whole square. Previous sum it is only x. Therefore x plus delta x we retained. Since the function is squared, so you have to write x plus delta x whole square. This you expand now. X square plus 2x delta x plus delta x whole square. Here this side y plus delta y. This is my second equation. Now equation 2 minus equation 1. Same like previous sum. Y plus delta y minus y is equal to x square plus 2x delta x plus delta x whole square plus delta x whole square minus first equation is x square. So we have written here 2 minus 1. What is 1? 1 is called first equation. Both we are subtracting from left hand to left hand, right hand to right hand. Left hand side we are having y plus delta y. First equation is y. So left hand side y plus delta y minus y. Right hand side you are having this x square plus 2x delta x plus delta x whole square minus x square. Cancel x square and x square. Now y and y also cancel. Delta y is equal to, you are left with now 2x delta x plus delta x whole square. Divide by delta x both sides and apply limit delta x tends to 0. Then what you will get? First you have to divide delta y by delta x and put it as limit delta x tends to 0. And right here limit delta x tends to 0, 2x delta x plus delta x whole square. Each term you should divide by delta x. Do not forget, because we wrote here both sides. So delta x will go away. This will go one time. So when you put limit delta x tends to 0 this side, you'll be getting 2x because there is no delta x term here, plus 0 will be because delta x becomes 0 here. So this is 2x. This will become now dy by dx. So now, so when function is y is equal to x square, what you got now? Y dash means differentiation is equal to 2x. Hope you understood this. So, for example, similarly, you can say for y is equal to x cube. For y is equal to x cube, the same way we can do. For this, y dash will become 3x square. You can practice this. So by seeing these notations, you will understand that if y is equal to x to the power of n, differentiation of y with respect to x is given by n into x to the power of n minus 1. So now this derivation I will finish for you for today. So differentiate, this is the third sum I think. Differentiate y is equal to x to the power of n from first principles. So now from first principles we are defining. Start again with the same way. Let y is equal to x to the power of n. This is the first equation for us. Same sentences. Let delta x be an increment in x and let delta y be the corresponding increment in y. So therefore, y plus delta y is equal to x plus delta x whole to the power of n. So by binomial theorem, you have to apply here. It will become x to the power of n. I'll write that binomial word here for you. So by binomial theorem, I will put three terms here for you. X to the power of n plus n into x to the power of n minus 1 into delta x plus n into n minus 1 by 2 into x to the power of n minus 2 into delta x whole square dot 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 last term delta x whole to the power of n. Okay. This is called y plus delta y. So last term is delta x whole to the power of n, remember. If you want that, I will write more further clear. Delta x whole to the power of n. So remember this. Now go to the next page. Equation 2 minus equation 1. So what is our equation 2? This is my equation 2. This is equation 1. So I'm labeling this as equation 2. So 2 minus 1. Same like left hand side. F5 plus delta y in the second equation. First equation y is there. Here we are having x plus delta x, we expanded here. So x to the power of n plus n into x to the power of n minus 1 into delta x plus n into x to the power of here n into n minus 1. Third term will be n into n minus 1 by 2 into x to the power of n minus 2 into delta x whole square dot 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 delta x whole to the power of n, last term. So now here minus first equation, second equation is over. First equation we are having x to the power of n. So x to the power of n, x to the power of n get cancelled. Here y and y will get cancelled. So we are left with now delta y is equal to n into x to the power of n minus 1 into delta x plus n into n minus 1 by factorial, 2 into x to the power of n minus 2 delta x whole square plus dot 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 delta x whole to the power of n. Now divide by delta x throughout. So the procedure doesn't change. Divide by delta x throughout and apply limit delta x tends to 0. Then we will be getting delta y by delta x limit delta x tends to 0 limit delta x tends to 0 delta y by delta x is equal to limit delta x tends to 0. Right hand side we are having n into see the equation, top equation, n into x to the power of n minus 1 delta x by delta x first term plus n into n minus 1 by 2 into x to the power of n minus 2 delta x whole square divided by delta x and dot 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 plus delta x whole to the power of n divided by delta x. So this I can write now dy by dx. So here delta x and delta x will get cancelled and in all other terms you find the delta x. So just for last step I'll write this one clearly for you. This delta x will go one time here, n into n minus 1 by 2 x to the power of n minus 2 into delta x dot dot dot. In all terms delta x will be there. Last term is delta x whole to the power of n minus 1, you can write down. So if you apply delta x 0 here, except the first term, rest all terms become 0 because everywhere delta x is present. So in the place of delta x, if you write 0, this vanishes, this vanishes. So you will be getting only n into x to the power of n minus 1. So therefore, d by dx of x to the power of n is equal to n into x to the power of n minus 1. Very, very important formula. So therefore, I told you in the previous case, if you are having d by dx of, let us say, x to the power of 4. What is the answer? Here n is equal to 4. So n into x to the power of n minus 1 is answer. 4 into x to the power of 4 minus 1, that is 4x cube. So d by dx of x to the power of 10. Very simple. 10 into x to the power of 9. So this is how we can derive. Finally, d by dx of x to the power of p, if they give p into x to the power of p minus 1. So hope with these examples you have understood the how to apply the first principles to find the differentiation. All the time they don't ask first principles, only whenever they ask we are supposed to do this fashion. So repeatedly go through the examples what I did, understand them and apply your own way, your own sums and then try to practice. So friends, in the next video, I'll be presenting these first principles for certain functions, trigonometrical and logarithmic, and then try to apply the differentiation formula over there. Okay. Thank you, friends. Keep watching the videos.